Polynomials are a type of mathematical expression that we're going to work with a lot in this class and, of course, moving forward. And what we're going to focus on in this video is how to add and subtract polynomials. So first of all, when we talk about polynomials, what are we referring to? A polynomial is a sum of terms that have the form a times x to the n, where a is just a number and n is a whole number, right? And the other thing it's important to make sure we're clear on is this when we say terms. When we talk about terms, that means things that are separated by addition. Now, when you look down at this expression here, this is a polynomial, and that is a minus sign, obviously. Well, x to the seventh and 5x to the fourth, those are, and I guess negative 5x to the fourth are different terms, right? The reason why when we say separated by addition, it still encompasses things like this is because you could always say x to the seventh plus negative 5x to the fourth, right? So really, if they're separated by addition or subtraction, then we're referring to various terms. But the exponent has to be a whole number. So this one that I underlined is a polynomial, but this one over here is not because this x is being raised to the negative 3 power. Now, at first, you also might look at that plus 1 at the end of this one and say, well, wait, does that fit the definition? It doesn't look like a times x to the n, but we could write it like this, right? Because we know x to the 0 power is equal to 1. And so it does fit this definition because 0 is a whole number. All right, we'll refer to specific polynomials by name throughout the coming sections. So when we say monomial, that means a polynomial with just one term. So something like this, 4x to the third. If that's it, that's a monomial. A binomial is one with two terms. So 5x squared plus 3. And a trinomial, get the idea now, I'm sure, a polynomial that has three terms. One of the things that we're going to be interested in when we are talking about polynomials is both the degree of the term and the degree of the polynomial. Okay, so when we talk about the degree of the term, what we're referring to is the exponent of that term. So 3x to the fifth, that has a degree of 5. 2z, right, of course, is equal to 2z to the first. So the degree of that term is 1. And then 8 is 8x to the 0. So the degree of that term would be 0. So when we talk about the degree of a polynomial, what we're referring to is the highest degree of any term that happens to be in the polynomial. And so in this example, I just scan each term. Which one has the highest degree? Well, of course, that'd be this one. So it has a degree of 6. So what I want to talk about now, though, is when we have polynomials, we do want to make sure that they are in the most simplified form that we can get them. And so what that means is combining like terms. Okay. So first of all, when we're talking about like terms, there are two requirements. We need them to have the same variables, and those variables raised to the same power. All right. And so when we talk about simplifying in the context of polynomials, Simplify means that we are going to combine like terms. These two little things that I wrote out here are things I probably should have written out in the notes or typed out in the notes, but sorry, I didn't. So make sure you get those down to make sure we're clear on what does it mean to what are like terms, and then understanding that when I say simplify, I mean combine like terms. So in this example, I can see that, make myself a little bit of space here. I can see that I have 14y squared and minus 10y squared. Those are like terms, right? They both have y's, and those y's are both raised to the second power. And the 3 and then minus 9, those are like terms because they don't have any variables. And so they match up with each other. And so this second step here, maybe you won't find necessary, but just to be really clear about what's going on, I'm going to put the like terms next to one another. Just when you move things around, make sure whatever symbol's in front of that coefficient follows it. So these two like terms, of course, 14y squared minus 10y squared would simplify to 4y squared. And then 3 minus 9 is going to be minus 6. So here's my simplified polynomial expression. All right, the example below is another one where we can see that there are some like terms involved. Of course, I have to up the challenge level a little bit here, and I gave you some fractions to deal with. So, but nothing really changes, right? Maybe as a first step, I'll put any like terms next to one another so I can see that. Um, and you know what? It's never a bad idea. It's like, just underline maybe in different colors, or if you don't have different colors, you can do things like this. You can say, um, I underlined the x cubed like terms, and then I can see that this one and this one are also like terms. And then the plus two is just kind of lonely by itself there. So I might start by putting the 2/7 x cubed and the minus 1/2 x cubed next to one another so that they're ready to be combined. Same thing with the minus 1/4 x and the plus 3/8 x. And then plus 2 doesn't have any terms that are like it, so we'll just put it at the end. One of the things I've also done here is I've put the highest degree term first, and kind of wrote in what it's called descending order. Highest degree term first, lowest degree term last. So that's kind of a convention that we'll find helpful. And so, something to try to remember to do. All right, so of course, to combine fractions, we're going to have to get some common denominators, right? So for these two, we've got a 7 and a 2, which share nothing in common, so we'll just multiply them to get our LCD. So I understand that I'm going to end up with things that have 14 on the bottom. And sorry, I didn't give myself enough space there. Let me fix that. So 14 on the bottom, x cubed, minus 14 on the bottom, x cubed. So to make the 14 on the bottom of this one, I got to multiply top and bottom by 2. And multiply the top and bottom of this one by 7. And then for these two, clearly the LCD is just 8, least common denominator. So we'll have minus, so I have to multiply by 2 on top and bottom, make my common denominator there. This one I don't have to do anything to, right? It's good the way it is. So now I can combine these. 4 minus 7 is negative 3/14 x cubed plus 1/8 x plus 2. All right. Now here's just a few more for us to work on. Let me start by just looking at part B and just giving a friendly reminder that when we are subtracting polynomials and you're subtracting off a polynomial that's got multiple terms in it, that the first order of business always has to be to distribute your minus sign through. Now, at first, that might seem kind of awkward. What do I mean by distribute the minus sign? Well, remember, you can always just shimmy a little one here. So when you think of the distribution, you can think of it as we are distributing -1 through to each term, right? In other words, multiplying each term by -1. So these terms here just come down, and I can drop the parentheses because they're not really doing anything. But then as I distribute the -1 through these terms, then I can drop the parentheses there as well. So -1 times that is positive 3a squared minus ab plus 7b squared. And then as we've done in the past, we can put together, if we'd like, we can reorder so that we put the a squareds next to one another. We can put the ABs next to one another. And by the way, it's okay to have multiple variables, right? But this and this are like terms because they have multiple variables, but it's the same multiple variables raised to the same powers. So those are like terms with one another. And then plus 6b squared plus 7b squared. So of course that can combine into 5a squared. And then minus, you can always think of it as a 1 times AB and a 1 times AB. So it would be minus 2AB plus 13B squared. All right. Why don't you hit pause and try parts A and C yourself, and then go ahead and unpause it, and I will work through those couple, and then we'll make sure we get to the same answer. All right, so in part A, we have all these parentheses here. We're saying this polynomial here plus this polynomial here. But since it's just a plus, we don't really have to do anything with these parentheses. So, they don't really need to be there, unlike the second set of parentheses in part B. So we'll just write it without them. And then, of course, 3x squared plus x squared, put those next to each other. In these big polynomials, sometimes it's good to like make little markings once you've rewritten something, right? Like I've written those, so I underline them. Then I'll put plus 2x, underline that, and then -1 minus 7. So I make sure that I've got everything. All right, 3x squared plus 1x squared is 4x squared plus 2x minus 8. Now I should say, the reordering and putting like terms right next to each other, um, that's an optional thing to do. So it'd be okay just to jump straight from here to here if you're comfortable with that. But it can be helpful, especially the bigger the problem, to put the like terms next to one another. All right, so then in part C, we have a similar situation to part B. I've got this minus out here, right? And you don't have to shimmy the one in there, but it's just a helpful thing for a lot of folks to remind themselves of what it means. Here we have to distribute this -1 to 4 different terms. So we end up with 4x cubed plus 7x minus 9, and then plus 2x cubed minus 7x squared plus 8x minus 13. So making sure that negative changes the sign on all of those terms. And again, my optional step, though, in this case, I think it's kind of helpful because there's so many terms. Looks like there's only one x squared term, so I'm writing it in descending order here. 7x plus 8x then minus 9 minus 13. So 6x cubed minus 7x squared plus 15x minus 22.